Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's biweekly contest, maximum number of operations with the same score 2. The problem is a application of dynamic programming. If you have been following this channel for a while now, I'm very sure you will be able to approach this problem by yourself. If you haven't tried this problem yet, I would encourage you to pause the video right away and give this problem a try. With that, let's get started. The problem states that you are given an array called nums and you can perform any of the following operation while num contain at least 2 elements. And the operation is you can choose the first 2 elements and delete them. You can choose the last 2 elements and delete them. You can choose first and the last element and delete them. So the score of a particular operation is determined by the sum of the deleted elements. So in this case, the score will be the sum of first and the second element. In this case, the score will be sum of last and second last element. And in this case, the score will be the sum of first and the last element. So the task is to find out the maximum number of operations that can be performed such that all the operations have the same score, right? So you are allowed to perform any number of operations, but the constraint is whatever operation you are performing, that should all have the exact same score. And you have to figure out the maximum number of such operations you can perform, right? So let's take an example. Let's say the array nums is 3 2 1 2 3 4. So in this case, we want to figure out the maximum number of operations that we can perform on this array such that all the operations have the same score. So let's start with this. That is, we are applying the first operation. Choose the first 2 elements and delete it. So if you choose the first 2 elements, the score of this removal or this operation would be 3 plus 2 5, right? Now because the score is 5, we are now bound that any other operations we are performing that should have a score of 5, otherwise will not perform that operation, right? If we need to start with 3 plus 2. So we remove this 2. Now we are left with 1 2 3 4. Now if you choose operation 1 again, the first 2 elements and delete them, this operation is not a valid operation because the score of this operation would be 1 plus 2 3, which is not equals to the previous operation, which is 5. So one valid operation in this case is 1 plus 4. You take the first element and the last element and delete it. It is operation number 3. This has the same score because the score would be 1 plus 4, which is 5. Now finally you are left with this array. You can simply take these 2 elements. The score will exactly be 5 again. So this is a valid operation. So in total you are able to apply 3 operations with the same score, that is 5, and hence the answer here is 3. That is, you are able to apply maximum 3 operation. You can't apply more operation because the array itself is now empty after applying these 3 operations. So you don't have more elements as well to apply the operation, and hence the answer here is 3. Also notice that this answer 3 we will get from a particular sequence of operations, right? So if you are not following that sequence, that is, you apply the first operation first and then you apply third operation first and then you apply the first operation again. If you don't follow the sequence, you will not get 3. So 3 is the maximum possible number of operations you can perform, right? So hope the problem statement is clear. Now how to solve this? So let's start with the brute force solution. What is the brute force solution? Simplest way is to just simulate whatever is given. The problem states that you need to perform the operations and you need to find out how many maximum operations you can perform such that every consecutive operations has the same score, right? So one of the brute force way could be, okay, I will enumerate all possible sequence of operations. So we have this size array size n, let's say. So how many operations you can perform at max? N by 2, right? That's the max number of operations you can perform. So what you can do, you will say, okay, I will perform n by 2 operation in a particular fashion. Let's say I will perform operation 1 first, then I will perform operation 2, let's say, I will again perform operation 1, let's say, then I will again perform operation 3, then let's say 1, and then let's say 1. So basically you are applying a sequence of operations. Now in the same fashion there will be multiple such sequence. Now for each such sequence you can figure out what is the maximum number of consecutive operations with equal score you are getting. So what is, let's say you are applying operation 1 here. So what is the score of operation 1? Operation 1 score is 1 plus 4, 5. Again, operation 1 is nothing but choosing first two element, operation 2 is choosing last two element, and operation 3 is choosing first and the last element. So we have chosen operation 1 here, so the score of this operation would be 1 plus 4, which is 5. Now we have chosen operation 2 now, that is the last two element, so again the score is 5. Now operation 1, again score is 5. Now operation 3, the 3 plus 1, 4, right? Operation 3 score is 4. Operation 1, 2 plus 4, 6, and then finally operation 1, 3 plus 2, 5. Now in this case, if we have followed this sequence of operations, what is the maximum number of valid operations that we can achieve with the same score? In this case 3. So for this particular sequence of operations, you are getting, or you can apply at max 3 operations such that each of them has the same score, right? In the same fashion you can try out all possible combination. For each of them you will get some maximum score that you can achieve, and for after getting the maximum score for each of the combinations, you can simply take the max out of it, and that will be your final answer, right? So because we are trying out all possible combinations of all possible sequences of operations, there is no doubt about the correctness of the solution, because at least one of these sequences will give you the maximum number of valid operations, right? So what is the time complexity? The time complexity would simply be number of operations you are able to perform, right? So in this case, so the number of sequences that you can have, let's say number of sequences is S. Now for each sequence, what you're doing, you are figuring out the cost for each of the operation, and then figuring out what is the total number of consecutive operations which have the same score. So finding out the cost will take you order and time, because you need to iterate over the array and figure out the cost. So that will take you order and time. So the time complexity is S into N, which is where S is the number of sequences. Now how many sequences can be there? Notice there are n by 2 spaces, and each space you can fill in 3 different ways, either 1, 2 or 3, right? So for each space you have 3 ways, and you have total n by 2 space. So the value of S will be 3 into n by 2, 3 power n by 2, and multiplied by n will be the overall time complexity. So this surely will not pass, because the value of n is very huge, 2000, right? We need to optimize this. And given that we know the fact that we can't actually enumerate all the operations, we need to come up with some logic that doesn't require enumeration of all the sequences of operations, right? So how to optimize the solution now? So let's fix the first operation, because once you fix the first operation, you know what is the score you are looking for, right? So let's say you fix the operation as 1. Again, the first one can have 3 different values, either 1, 2 or 3. So either you have 1 here, or you have 2 here, or you will have 3 here, right? So we'll try each of these. So let's start with 1. If you take 1, that is, you are saying that I will be doing operation of type 1 first. So operation of type 1 has a cost of 5, right? So now you know whatever operation you want to do, those all should have a cost of 5 to be a valid operation. You don't care about the operation that give you a cost which is not equals to 5, because that will not give you the maximum result you're looking for. So somehow we need to figure out now how many consecutive operations you can do such that each of them sums to 5. right? Now let's talk about the case where you put 2 here. So if you put 2 here, the first operation you are doing is taking the last 2 elements and summing it up. So again, the sum is 5. So what you're looking for is how many consecutive operations you can do such that the sum will be 5. Sum of each operation will be 5. Now finally, the third operation, third type of operation. So if you do this operation first, you will be getting a sum of 2. So what you want, how many consecutive operations you can do such that it has a sum of, everyone has a sum of 2. So isn't all these problems sounds exactly similar? The first one says how many consecutive operations you can do such that the sum is 5. Second one says how many consecutive operations you can do such that the sum is 5. Third one, how many consecutive operations you can do such that the sum is 2. So all of them are exactly same problem, right? So hope you can see some kind of recursion, like you might get intuition, okay, if they are same problem, maybe you can use some kind of recursion here, and that's the key. So let's say you use the first operation. So what you have, you now have removed these 2 elements from your array. The array that you are remaining with is this array. Now what you want in this array, how many consecutive operations you can apply such that the cost of each of them is 5, right? So the same thing you want for this one and this one as well. The sum will change, the array will change, but the question will still remain the same. What you want is still the same. How many consecutive operations you want, you can do such that the sum is equals to some particular value. In this case, in the first case it is 5, second case it is 5, the third case it is 2, right? So let's take a function here that can give us this value. So f of l comma r comma sum. Now why 3 things? Because we know the remaining array, like the array we want the value in, will not be the same in each of these. In the first case, the remaining array is this particular case, this particular array. Similarly, in second case, the remaining array would be this part of the array. Similarly, in third case, the remaining array would be this part of the array. So the remaining array in which we want the answer in is changing, and that's what we denoted by l comma r. Basically, L will say what is the start of the array which we care about and what is the end of that array which we care about. So we will care about only the array that lies between L and R. Now for this array, give me the maximum consecutive operations such that the sum of each operation is S. So that's what this function denotes. Now once you have this defined, notice that you have only 3 kind of operations. Either you can apply operation 1, or you can apply operation 2, or you can apply operation 3, right? So for operation 1, what you will do, you will say, okay, I will remove first 2 elements, that is I will remove array of L and array of L plus 1. Now how to check whether operation 1 of the operation you are applying is valid or not? The sum should be S, otherwise this operation is not valid, right? So if the value of array L plus array L plus 1 is equals to S, then this operation is valid. That is, you can apply the first operation, and after applying the first operation, let's say this is L and this is R. So after applying the first operation, you want to ask, okay, how many consecutive operations I can make such that the sum is equals to S again in this reduced array. So you can say how many consecutive operations I can make in the reduced array L plus 2 to R such that the sum is S. Whatever answer you will get, you will do plus 1, and that will be one possible answer for f of LRS, right? Why plus 1? Because you just now did one operation, right? So that's where plus 1 comes from. Similarly, for 2, you can apply operation 2 in this state. So if you apply operation 2, what you are doing, you are removing the last 2 elements, right? Now whether you can do this or not is a different question. And how to determine? Again, if array of R plus array of R minus 1 is equals to S, then only you can apply operation 2, otherwise operation 2 is not valid. So if it is valid, if you can apply this, then from this path you will get how many operation or how many consecutive equal operations, L comma R minus 2 comma S, right? You are saying that okay, in this reduced array, give me the maximum number of consecutive operations I can apply such that the sum is equals to S. Now whatever you are getting, you will do +1, and that will give you the value of one possible value of f of L comma R comma S. In the same fashion, you can apply operation 3 as well here and check whether it is valid or not before applying. How to check? Again, array of R plus array of L should be equals to S, otherwise you can't apply this operation. And if you are able to apply this operation, the value of FLRS, or one possible value of FLRS, is 1 plus f of L plus 1 R minus 1 and S. Now once you get all possible values, you can just take the max across all of them, and that will be the value of FLRS. That is the maximum number of operations you can apply in the array of range L to R, such that the sum of every operation is equals to S, right? So hope the approach makes sense. Let's do a dry run over an example before jumping to the pseudo code. So I have just modified the array a bit, and let's say you want to find out f of 0 comma 11 5. That is, you want to find out, given this entire array, tell me how many consecutive operations I can apply such that the sum is 5, right? So you will do this for all possible sums, and finally you will get the answer, right? So you are saying give me the maximum number of operations for this range with the sum of 5. So what will be the value? Again, at this stage you can apply 3 operations, either the first one or the second one or the third one, right? So let's start with the first one. So if you apply the first operation, the value of this operation would be, or the score of this operation would be 1 plus 4 5. And what is the score you're looking for? You are looking for 5 only. So this is a valid operation. So if you apply this operation, you have applied one operation, and you are saying okay, I have this remaining array, so tell me how many operations I can perform such that the score of each of them is equals to 5. So the remaining array is 2 to 11, and you want a score of 5, so you say f of 2 comma 11 or 5, right? So this is one possible scenario where you applied operation 1 in here. Let's say you applied operation 2, that is, you removed, let's say, first and the last element, assume, right? So in this case, for this operation, what is the score? Score is 1 plus 1 2. What is the score you are looking for? 5. So at this state, you can't apply the operation where you are summing up first and the last element, right? Now the third operation is sum of last 2 element. So in this case, the sum of last 2 element is 4 plus 1 5. So again, the sum is equals to what you are looking for. So this is a valid operation. Because this is a valid operation, you want to know how many maximum number of consecutive operations you can get if you have done this operation now. So for that, you will say okay, I have removed the last 2 element. Now this is the array remaining. Give me the maximum consecutive operations I can apply such that each of them sums up to 5. So what you want? You want f of 0 comma 9 comma 5. So 0 comma 9 comma 5, right? So let's figure out f of 2 comma 11 comma 5. Again, what will be the answer for f of 0 comma 11 comma 5? It would be maximum of 1 plus this comma 1 plus this. Whatever is the maximum across these two will be the answer for f of 0 comma 11 comma 5. Why? Because from here you can have 2 possible valid operations, and if you apply those operations, these are the states. So you will say okay, if I apply this operation, how many maximum operations I am getting, or maximum consecutive equal 4 operations I am getting. If I apply this operation first, how many maximum consecutive equal operations I am getting, and whichever gives me the maximum, that way I will go. or that operation I will apply first, right? Remember the 6 places we have filled something here. Now we are wanted to find which sequence will give us the maximum benefit. So we want to fill something here. So that's what we are determining by saying whichever is maximum, I will go there. So if I go here, then it means I am filling this with 1, right? So that's just a way to visualize it. Now you want f of 2 comma 11 comma 5, that is L is this, R is this. You want what is the maximum number of operations I can apply such that the score of each of them is 5. So again, at this stage you can apply 3 different operations, this or this or this, right? So let's start with the first one, 4 comma 1. So if you apply the first operation, that is remove the first 2 elements, the score would be 4 plus 1 5, which is equals to what you are looking for. So this is a valid operation, and if you apply this operation, you will remove the first 2 elements and say, okay, I have remaining with these elements, let me figure out, or let me know what is the maximum number of operations I can apply such that the score will be 5. So I will just figure out the value of f of this will be 4, f of 4 comma 10 comma 9 4 comma 10 comma 5, right? So once you have this sorted, you will now figure out the value of f of 4 comma 11 comma 5. So let's just make it 4. So f of 4 comma 11 comma 5 is what we are looking for. Oh sorry, f of 2 comma 11 comma 5 we are looking for. We have applied the operation 1, and for that we saw that this is a valid operation because for this we are getting a sum of 5. Now we are trying to apply operation 2, that is the sum of first and the last element, let's say. So in this case the sum would be 5. Again we are looking for 5 only, so this is a valid operation. Now if you apply this operation, what is the remaining array which you need to figure out the answer for is 3 to 10. So you will just say okay, I think there is something wrong I have done here. So this is operation number 1 where I remove the first 2 elements, right? And now this is operation number 2 where I remove the first and the last element, that is this and this, right? And this is operation number 3 where I remove the last 2 elements, so the remaining array would be 2 to 9. So again, all of these are valid because all of these operations yields a score of 5. So after applying these operations, you now want the value of this, this and this. Now what will be the answer for this, or how many maximum operations you can apply in the range 2 to 11 with a score of 5? That will be the maximum across all of these, right? So now we have to figure out f of 3 comma 10 comma 5, f of 4 comma 11 comma 5, and 2 comma 9 comma 5. So for this, again the same thing, we are looking for f of 3 comma 10, this array, and we want a sum of 5. So 3 operations, this, this or this. So which of them are valid? The first is not valid because the sum is 4 and we are looking for 5. The second is valid, the sum is 5 and we are looking for 5. So if I go with second operation, I will be remaining with this array, that is 3 to 8. So 3 to 8, sum of 5. And the last operation is you take this one and this one. So if you do this, I will be remaining with this particular array. So the number of operations in the range 4 to 9 with the sum of 5. So let's figure out f of 3 comma 8. What is f of 3 comma 8? 3 comma 8. So here you can apply again 3 operations. Let's start with the first one, 1 plus 3. 1 plus 3 is 4. You are looking for 5. Not a valid operation at all. So you will not do this operation at all. Second operation, 3 plus 5, 8, looking for 5, so not a valid operation. 1 plus 5, 6, but you're looking for 5, not a valid operation again. So at this stage you are not able to apply any operation, so you will simply say I can't apply any operation, that is number of operations I can do is 0. In the same fashion, the number of operations for this state as well will be 0. So what will be the answer for this one? Answer for this one would be 1 plus 0, 1 plus 0, and maximum across these two. So maximum across these two would be simply 1. So the answer for this one would be 1. In the same fashion, this will be 0, this will be 0, this will be 0. Again, notice 4,9,5 is something we have evaluated already, so this whole thing will be 0, and 2,8,5 will also be 0, because I think this is 3,8,5. So this is also 0 because we have evaluated this already. So finally, this will be 1, this will be 1 as well. Now what will be the value of this one? Again, maximum across all of them plus 1. So maximum across all of them is 1. So value for this one would be 2. Now finally, to find the value for this one, we need the value for this and this. So what is the value for f of 0, 9,5? 0, 9,5. So again 3 operation, this and this one. So if you see, only this operation is valid. So you only want the value of 2, 9,5. So the value of 2, 9,5 is something we already calculated. It is 1. So the value for this will be 2. And finally the value for this will be 3. That is, you can apply at max 3 operations that has the exact sum of 5 in this array range, right? So hope this entire solution makes sense. Now let's look at the pseudocode. The pseudocode will be exactly similar to what we just have done manually. We have a function f of l, r, sum. These are the base cases. Firstly, we say if l is equals to r or l is greater than r, that is, we don't have enough elements, or we don't have at least two elements to perform any operation, we simply return 0. Otherwise, we have 3 operations to perform, and each of these operations we can perform if the score of the operation is equals to the score we are looking for. So the score of the operation, of the first operation, if it is equals to the score we are looking for, it is a valid operation. So because it is a valid operation, I can apply this operation, and whatever is remaining, I can just ask the function to give me what is the maximum operation I can apply to the remaining array. In the same fashion, if the score for the second operation is also equal to what we are looking for, we can apply that operation and just figure out what is the maximum number of operations I can apply in the remaining array. And same for the third one as well. You will take the max across all of them, and that will be your answer. Now notice, you also need to do memoization, because if you don't do this, the complexity will be exponential, and we have already seen a lot of times that there will be a lot of duplicates here. F of 4, 9,5, 4, 9,5, f of 2, 9,5, which occurred again. So there will be duplicates. So if you memorize it, then you will be able to answer duplicates without any further computation. So we are simply memorizing it before, so that we don't need to answer or calculate the value for the duplicate questions. So here, if you we simply put the value after calculation in a DP array, and simply returning that if with DP array already have something for that particular state, that is l, r, sum. Now what is the overall time complexity? If you do this naively, the complexity would simply be number of states multiplied by what you are doing inside each of the states, because each state you will be computing exactly once because of this DP array, right? So how many states you have? First of all, what you're doing inside each of these states, you are simply doing 3 mathematical operations. So order 1 is what you are doing inside each of these states. Now how many states are there? Number of distinct value of L, number of distinct value of R, and number of distinct value of sum. So number of distinct value of L would be n, number of distinct value of R would be n, and number of distinct value of sum would be the maximum sum of 2 elements, which is 1000 plus 1000, which is 2000. Again, 2000 here will be equals to n as well, which is the worst case value of n. So in worst case, the value or the sum, the complexity would be order n cube, which again will not pass because the value of n is 2000, so n cube will not fit in the given time constraint. So you need to optimize this. So optimizing from here onwards is very easy. So would encourage you to pause and try to think by yourself. So hope you thought about it. The optimization, first of all, there are 3 things. 2n coming from the fact that you are looking at 2 array. Third n is coming from the fact that you are looking for a particular sum, right? Now removing first two is a bit difficult, because if you remove first two, it means you somehow magically figure out what is the length of the remaining array. That is also difficult. So notice the third one. Third one can be removed easily. Why? Notice this state, this entire state. The value was constant across everything, right? Because we were looking for one exact sum. The value was constant across the board. And because the value was constant, you can actually remove this from your DP state and move it as a global variable, right? So this will be gone, this will be gone, and this will be gone. Overall, the complexity would simply be order n square. Now, I think you might already have guessed it. If we are not considering sum at all, how we will tackle these scenario? If you remember, we started with this, that on the first position I can either fill 1, 2 or 3. That is, I can do either the first operation first, or second operation first, or third operation first. If I do first operation first, then I need what is the maximum number of operations I can have which has a sum of 5 in the range this L to R, right? For the second one, if I do the second operation first, I may have different sum. In this case, the sum was actually same. So we are saying how many maximum number of operations I can perform in a different array such that the sum is 5. Now for third one, the sum was exactly different, is 2. So how many different operations I can perform such that the sum is exactly 2 in this part of the array. So sum is also changing across these three, but it is changing exactly thrice. So we can have at max 3 distinct sum, right? So instead of keeping sum entirely here, we can reset everything and compute it for 3 different sum. First sum, where the value of this would be the score of the first operation. Second sum, the value would be the score of the second operation, and third sum, the value would be the score of the third operation. One of these 3 sums will be there always. So your choice, either you compute everything for 3 distinct times, that is, you reset everything here and compute f of L comma R with 3 different if with one particular sum you compute all L comma R, store it somewhere, then you compute f of L comma R for all L and R for a different sum, again store it somewhere, then you compute f of L comma R for different sum, again store it somewhere. So in total you will be doing order n square operation at max 3 times, and hence the complexity is still manageable. So basically the value of sum here can be 3 distinct values. So instead of actually putting out sum, you can think of it, you are putting out either 0, 1 or 2. 0 denotes what is the sum when you apply the operation 1, 1 denotes what is the sum when you apply operation 2, and 2 denotes what is the sum when you apply operation 3. So either you can keep sum, but instead of actual value you can put 0, 1 or 2 kind of hashing, or you don't put sum and you say, okay, I will compute everything 3 times, right? So next we'll be looking at the code, but if you watched this point, I would strongly encourage you to code this entire thing by yourself, because that's the point you will be able to understand what piece is not clear to you yet. If you have any doubts, feel free to rewind the video and watch that particular section. So next we'll be looking at the code. In the code, I have computed everything thrice. I have completely removed this sum altogether and I have computed everything thrice. So let's look at it. So we have this function max operation with a particular sum, and we are saying that if this is the sum, then how many maximum operations I can have in the entire array. If this is the sum, how many maximum operations I can have. If this is the sum, how many maximum operations I can have. And I will just take maximum across all of them, and that will be my answer. Now max operation will sum. What we are doing here, we are simply resetting the entire DP state, because whatever was valid for a particular L and R before may not be valid for a different sum, right? So we reset everything here, that is, we will recompute all the states again, and we simply call this max operations function with 3 parameters: 0, array size dot -1, which is basically the entire array L comma R, and this particular sum which we are looking for. Now notice this can be a global variable, this may not be, so this is constant across the entire state of the array, or entire state of the function you are trying to calculate. So this you can skip from your DP state altogether because it is constant. So the code is exactly what we have seen in the pseudo code. We will simply see if we have already computed it, or if there are enough elements to actually apply an operation. If there are enough elements to apply an operation, you can either apply the first operation, second operation, or third operation, depending on whether they are valid or not. And the definition of validity is the score is equals to the target score you are looking for, and based on that, based on the operation you are applying, you will figure out what is the total operations you can apply in the residual array as well. So you will take max across all of them, and finally that will be your answer. And notice we are also storing it inside the DP array as well, so we don't need to compute it again and again. So overall we will do this order n square operation 3 times in total, because this max operation will be called 3 different times, and we will be resetting everything 3 different times. So overall we are doing order n square operation 3 different times, and hence the complexity is still order n square, which is sufficient to pass the given problem. So hope the entire solution makes sense. If you have any doubts in any of the piece, feel free to follow up in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.